So today we will start with radical division. After seeing the videos of multiplication and after seeing radical multiplication, the division is going to be almost exactly the same. We will start today with division of radicals with the same index. To be possible to divide, it's the same as with multiply. When we multiply, we need to convert or have the same index in our radicals. If we have the same index like the topic of today, we only need to put all the radicals on the same one. We will do the algebraic division between the expressions and we will need to simplify the radicals. So it's going to be almost very simple. So let's see how to do it. On exercise 1, of course we can do it or we can put it in a single radical. So it's going to be on top 81x to the 7. On the bottom, it's going to be 9x. In this case, of course, 81 and 9, both of them are divisible. So we can divide it. But if we can do it also like decomposing the numbers. So 81 divided by 3, it's 27. Divided by 3, it's 9. Divided by 3, it's 3. Divided by 3, it's 1. This one is going to be 3 to the 4. X to the 7. On the bottom part will be 3 squared and x. We will see like, okay, 3 to the 4 and 3 squared is going to be only 3 squared on top. X to the 7 and x going to be x to the 6 on top. It's going to be 1 on the bottom. So I will have only the cubic root of 3 squared x to the 6. So let's see if it's possible to take out something. I can take out an x squared because 6 divided by 3 it's 2. The 3 squared will stay inside because it's not possible to take it out since the power it's smaller than the index. So my answer is going to be x squared that multiplies the cubic root of 9. And that will be my answer. So as I was telling you, after seeing the multiplication, the division, it's almost the same. When we have the same index, it's only putting both expressions on the same radical, doing algebraic simplification of rational expressions, and after that, like simplifying the radicals, taking out something if it's possible to take it out. Let's see another example. So on the next exercise, we can put it in a single rational and radical expression because we have a rational expression inside a radical. So it's going to be 48 x to the 5 divided by 3x cubed. So let's see. We can decompose the 48. If we decompose the 48, 2 it's 24, 2 it's 12, 2 it's 6, 2 it's 3, and 3 it's 1. So this one is going to be 2 to the 4, that multiplies 3, that multiplies x to the 5, all of it divided by 3x cubed. So what happens next? We can simplify it, this 3 with this 3, x to the 5 and x cubed, it's going to be only x squared. So I will have the fourth root of 2 to the 4 x squared. So in this case, I can take out a 2. And in the inside part is going to be the fourth root of x squared. That can be an answer. This one can be an answer. But let's see other stuff. When we have a power and the index that both of them are divisible by the same number, we can simplify it. Why? Remember, the idea is we divide the power by the index. So 2/4 is the same as 1/2. So this one we can put it as 2 that multiplies the square root of x. And that will be the most simplified answer because the power and the index are divisible, so they can get simplified, and that will be my final answer. So in this case, as I was telling you, it's simple to do. We only put them in a single radical, and we simplify it and take out whatever we can take out. Let's see another example. So let's see this one. Of course, we can put it on a single cubic root, and it's going to be minus 81x to the 7 divided by 3x squared. So let's decompose the 81. The 81, it's 3, 27, 3 it's going to be 9, 3 it's going to be 3, 3 it's going to be 1. So this one, first we can take out the minus sign because it's an odd root of a negative number. So it's going to be 81x to the 7 divided by 3x squared. So if I decompose it, it's going to be minus the cubic root of 3 to the 4 x to the 7 divided by 3x squared. So we can simplify it, and it's going to be minus the cubic root of 3 cubed x to the 5 divided by 1. So it's going to be only minus the cubic root of 3 cubed x to the 5. So let's see whatever it's possible to take out. I can take out a 3. I can take out an x on the inside part because the division between 5 and 3 it's not an exact division. I will still have x squared because the remainder between dividing 5 and 3 it's going to be 2, and that's going to be my actual answer. So as I was telling you, having a radical division when they have the same index, it's very simple. We can put them on a single radical, and after that we will be able to do an algebraic simplification and also a radical simplification, taking out whatever it's possible to take out. So let's see another example. So let's see this one. First of all, we can put it in a single radical. So it's going to be on top 1296 x cubed y to the 18, all of it divided by 27 x to the 11 y squared. So after this one, let's decompose the 1296. We can divide it by 2, and it's going to be 648. We can divide it by 2, and it's going to be 324. We can divide it by 2, and it's going to be 162. Divided by 2, it's going to be 81. Then it's going to be divided by 327, divided by 39, divided by 33, divided by 3, it's 1. So this one, we can write it as the fourth root of 2, it's 1, 2, 3, 4. So it's going to be 2 to the 4. That multiplies 3 to the 4, x cubed, y to the 18. And on the denominator part, going to be the 27, that it's 3 cubed, x to the 11, y squared. So we can do the algebraic simplification, and it's going to be the fourth root of 2 to the 4 stays on top, 3 to the 4 and 3 cubed, it stays on top, it's going to be only 3. X cubed and x to the 11, it's going to be on the denominator because it's bigger. 11 minus 3, it's 8. What happens with the y? It's going to be y to the 16 because it's 18 minus 2. So now we can take out whatever we can take out from the root. So let's see. On the top part, I can take out a 2, and I can take out 4 times y, so y to the 4, because 16 divided by 4 is 4. On the bottom part, the denominator, I can take out an x squared because it's x. 8 divided by 4, it's 2. And on the inside part, I will only have the fourth root of 3. And this is going to be my actual answer for this exercise. So the idea is very simple. As I was telling you, we only need to divide by putting on the same rational expression. Then we will do like a simplification of rational expression because we will have a rational expression inside. And after that, we will be able to take out something from the root, and that will be my answer. So let's see one more example. So let's see this one. On this one, we have polynomials. don't worry about it. They are on the same radical, so we don't need to change it. We only need to solve it. So it's going to be, as a coefficient, I have a plus 1, a minus 1. I need to factorize whatever I have inside. So it's going to be on top, on top we have a difference of cubes. So it's going to be a minus 1 that multiplies a squared plus a plus 1. The other one, it's a difference of squares, so we can factorize it at a plus 1, a minus 1. The one on the bottom, it's a perfect square trinomial, and it's going to be a plus 1, all of it squared. So what will happen next, it's going to be a plus 1 divided by a minus 1. We can simplify it, and it's going to be a minus 1, all of it squared, that multiplies a squared plus a plus 1, all of it divided by a plus 1, because we have 1 on the bottom part, we have 1 on top, so we can take it out, and it's going to be, if I take it out, it's going to be a plus 1, a minus 1. I can take out an a minus 1 on top, and it's going to be on the inside part a squared plus a plus 1, all of it divided by a plus 1. So we can eliminate this one with this one, and our answer is going to be a plus 1 that multiplies the square root of a squared plus a plus 1 divided by a plus 1. And that will be my answer. Of course, this one it's not rationalized. It's something that we haven't seen, but we will see on the next videos how to do the rationalization of the answer. But if not, that will be a possible answer because we haven't seen rationalization. So that will be it for today's topic, that was radical division when we have the same index.